Example 10 shows us how we can evaluate some functions and their inverses. We are given a couple functions here. We have our f of x and our g of x, and we're going to have to use both of those graphs to help us figure out our functions. Now, keep in mind that if you want to figure out your inverse of a function, your x and y's just change. So basically what I would recommend doing is writing out all of your ordered pairs. Here you have a negative 4, 4. At this point you have a 0, 2. This point is a, I'm going to guess that's a 1, 0. Here you have a 2, negative 1. And then here you have over 3, down 2. And then here you have a 4, negative 4. So if that's your function, then your inverse functions would be all the reverses. So that means your inverse for here would be a 4, negative 4. And then you have a 2, 0. You have a 0, 1, negative 1, 2, negative 2, 3, and you would have a negative 4, 4. So these are your f to the negative 1 of x. These would be your f of x. So what you're doing is if you're trying to find the inverse of 0, you're looking to find out where your x is equal to 0, but you're looking in your green ordered pairs. So we're going to find out x is equal to 0 at 0, 1. So if we want to evaluate this, your answer is just 1. So like I said, it's easiest if you list out your ordered pairs and then of your function and your inverse function. We're going to have to do the same thing here on g in a minute. Now for g, or for b here, you're trying to find g of f of negative 4. So that means we need to find f of negative 4, and that's not in green, that's not the inverse, that's going to be in red. So f of negative 4, we're going to evaluate that. So f of negative 4. If you go back 4, you go up 4. So that would be your y value is a 4. So if you take out this f of negative 4, that means you're really trying to find f of a, or g of a positive 4. So we're going to go over here to where x is equal to 4, and x is equal to 4 over here, and we go up 6. So we would say our answer is 6. So in this case, we have a composition of functions where you are evaluating one function, which is inside your parentheses, evaluate that, put that answer into your next function, and then evaluate that function at 4. Same thing happens on C, except we're going to start with a g of 0, and then we're going to plug that into the inverse. So we're going to try to find the we're going to evaluate g of 0. Well, g of 0 is just equal to 2. So there's g of 0. So if that's g of 0, then what we need to do is now we need to find f to the negative 1. I'm going to actually make this green because it's the inverse. F to the negative 1 of 2. So we need to find out where our x is a 2 in our inverse function. So x is 2, no, right here. So x is 2, which means your 0 is your value, your y value. So we're going to put a box around this. Now, for letter D is similar. However, what we have to do on D is, this is the same thing as saying, find g of the inverse of f of 2. That's just another way to write it. So we need to find the inverse of 2. So your inverse f of 2. If that's the case, find out where your x is 2. That'd be 0. So now what you're trying to find is g of, we're going to take out f to negative, or sorry, the inverse of f, and we're going to plug a 0 in here. So we need to find out where g is equal to 0. Now we're trying to use our actual function g. So this is where g equals 0. You go up, you get the answer of 2. So hopefully this will help you with some of the problems towards the end on page 67, and finding any other inverses or other functions, fun stuff like that. So Take care. Bye-bye now.